Okay, so I went ahead and taped it down, and then we're just going to add some additional relationships over here in our space to our right. So our perpendicular bisector was our green segment, that is TS. So I could write TS is perpendicular to CD. Okay, TS is a perpendicular bisector, and then since it's a perpendicular bisector, and I know these segments are equal distance, I'm going to have that to show TS is also perpendicular bisector to CD. And then here's our drawing conclusion. 3 dots in the form of a triangle. Therefore, okay, in my example I have up here, equal distance, CT is congruent to TD. Okay, and you could do the same thing. CS is congruent, is congruent to SD. So I know we didn't mark it on here, but if I already used 2 tick marks, this one would have to be 3 tick marks. So anytime I see equal distance, or anytime I see the box and the tick marks for showing a midpoint, then you are going to have to make sure you draw those conclusions correctly. Alright, so now we're going to open up. Let me zoom, back out. Because we have this folded in half. We're going to open up and we're going to look at some more vocabulary, and we're going to talk about examples with that. So this first thing, concurrent lines. That's when we have 2 or more lines. So in this first blank, I'm just going to put the number 2. And I'll scroll in or zoom in so we know what we're talking about. 2 or more lines that intersect at a common point. Okay, so an example of that is basically just having 2 or more lines intersect at the common point right here. That's my point of intersection. Well, whenever we have 2 or more intersecting at a common point, that point of intersection, okay, and I might have ran out of room, but it's called a point of concurrency. So I'm going to just draw an arrow up here to show that that is our point of concurrency, where that point of intersection happens. We're going to use this to help us understand special segments in a triangle. Now the first one we're going to look at is the angle bisector. We're going to use this angle ODG to construct with our compass, an angle bisector, and we're going to do it with patty paper. So the first way to do that is we're going to, let me get this little vertex for my D. I'm going to bring my increment in a little bit, but I want to create an arc that intersects the sides of the triangle. Okay, and I want to use that same increments for that arc. Sorry, let me get on this side. So this was this arc and the increment for this arc, and I'm gonna add my point of intersection for the arc, and we need to go ahead and name or label that point of intersection, and we can pick any point. I'm just gonna go with let's just go with S and E. Now I'm not changing my compass at all. Okay, I'm now just gonna put at the E and create another arc in the interior of the angle, and now put it at S and create the intersection of that arc. Oops, sorry. So we're going to label that point, that intersection. Oops, sorry. That's going to be A, and I probably should have put the A below. But we're now going to draw a segment or a ray from D to that point of intersection. And that is going to be our angle bisector. Okay. Now to show that it's an angle bisector, we're going to add an arc and another arc. And we're going to go ahead and show the relationship with these angles. Angle ODA is congruent to angle ADE. Okay? And I'm going to go ahead and highlight or label that this ray DA is the angle bisector. That is our angle bisector. I'm just going to write angle bisector. It's what's doing the cutting. Alright, now there is a theorem or property or relationship that happens with angle bisectors. Right here, points on an angle bisector, meaning points on this ray, my orange ray, they have a special relationship. It says right here, any point on the angle bisector is blank from the angle. Well, same as our perpendicular bisector, so it is going to be equal distance. Equidistant from the side of the angle. So we're making sure we're on the right track here. I went ahead and highlighted the angle bisector. Just understand that this is the side, and over here I can use that as that's also a side. We're gonna pick a point anywhere on our angle bisector. I'm just gonna pick a point right here. We're gonna go ahead and label that point. Let's label it. I don't think we use C, so let's just go ahead and put that C. So if it's equal distance, distance is always, when you measure it, has to be perpendicular. Okay, to get exact distance, it has to be perpendicular. So what we're going to do is we're now just going to draw a perpendicular line from point C, the point that's on the angle bisector, and to the side of the triangle, like such. So let's get that line drawn. And now I'm going to use my other piece of patty paper, or I can use the one I used earlier when I was tracing these segments. And I'm going to trace this segment, C. Oh, I need to label this point. Let's make that F. Okay, so I got CF. And then I'm going to create another line going from C to the other side of my angle. So I need it to be perpendicular. I'm going to create my intersection. I'm going to turn my paper just a little bit so I can make sure I get this perpendicular line segment. So as such, put our box to show it's perpendicular. Now, we traced CE. I know I didn't add that point, but I just want to just see, line it up. And right there, hopefully we see they are the same. To show equal distance, you have to add tick marks on those perpendicular segments, okay? And so I need to add the other point, and I apologize for that. But that should be H, okay? So CE, or CF, excuse me, is congruent to CH. Okay, it's equal distance to the sides because the point is on the angle bisector. Alright, so we're going to take another sheet of patty paper. We're just going to go over how to do an angle bisector with patty paper. So what I need you to do is, notice I'm not going in the center. I'm just going to go towards the top of my patty paper, and we're going to trace the angle ODG. ODG. And to make the angle bisector, okay, off the patty paper, we're going to, and I need to add, let me just add my letters, ODG. We are going to fold it, or cut it in half, fold it to make the bisector. And to do that, I just need to make sure that this side lies on, the sides lie on top of each other. So this side, you can put it towards the light if you need to, but I want to fold it so that my sides line up exactly on top of each other. Okay, going through the, and I'm just going to create a crease right there. And then there, that crease represents our angle bisector. So I'm just going to use my ruler to create that crease to show my, oops, sorry, to show my bisector. So add a little ray right there, and I believe this was A. So we have that constructed. It basically lines up, it matches, okay? And so we just saw on our first construction, we showed that if a point lies on the angle bisector, it's equal distance. Well, its converse is true too. So any equal distance, any point equal distance from an angle, from the side of an angle that lies on the perpendicular bisector. So if it lies on the perpendicular, if it's equal distance right here, then it lies on the perpendicular bisector, okay? So if I have my patty paper, my angle, pick up any point, and I want to make a perpendicular line, so I'll go down to the side to show that distance. Well, again, if I fold on my crease, trace my line, I will see that line goes from that same point to the side. So again, make sure you know you have to see these markings, and we need to see the arcs to show that it's an angle bisector to know that it's equal distance to the sides. The point on the angle bisector is equal distance. So now we're going to take this construction that we have and we're going to tape it down here as well. Alright, thanks for doing that, and we're going to go into the examples.